Hello, thank you for letting me talk to you today about scalable traceable solutions with New Relic and OpenTelemetry. I was really excited to be there in person for this New Relic user group. Unfortunately, I was called away to business in Kansas City, where I'm giving a very similar presentation to our Dev Days internal tech conference. So it's pretty much the same conversation, but I'm giving you guys it in advance. So, some of the goals of this talk is to give a little bit of a history of OpenTelemetry, some of its architecture and terminology. I want to talk about how OpenTelemetry can work with things like Zipkin, OTLP, CloudTrace, and obviously New Relic. We're going to do some example code using tracing with New Relic APM, the full version, as well as OTLP endpoint. And in doing so, we kind of looking at our lowest environments using Zipkin and kind of Elk and things on-prem. Maybe our middle tier would use the cloud of our choice. In my case, it'd be GCP. And then our upper environment, obviously, would use New Relic to monitor and trace things. And we'll talk about kind of what next steps we're looking at WellSky. So I'm going to write it in .NET. I am not a .NET expert. I'm more of an Express.js kind of guy. So I was, trying to learn up .NET for this project, and I definitely used a lot of AIs like Copilot and ChatGPT and Gemini. So there's a little bit of history of OpenTelemetry. Where did it come from? So around 2016, Twitter released Zipkin as a tracing standard, and go with it, Open Tracing as a way to watch it. The next year, Uber, more of a Java flavor, released Jaeger. Now we had two standards going on for doing tracing, Zipkin and Jaeger. In 2018, when Google released Open Census, the folks behind Open Census said, wow, our stuff's a lot like Open Tracing. Let's just become one new thing. That's how OpenTelemetry was born, and it added to the CNCF there in 2019. Start off in the sandbox level, which is really moving and shaking. And by 2021, it had graduated the incubating stage where things are a lot more stable. Now it's just all about adoption. So we can see it's in the incubating stage, and we have a lot of far more stable. And, we've had metrics and tracing for some time, and now we've added logs. So we expect to have everybody's getting behind OpenTelemetry. So what does the architecture look like? We have receivers, processors, and exporters. So receivers ingest traces, metrics, and logs. We have one or more of those. Processors are zero or more processors that sequentially process the data. We can do things like filtering, sampling, dropping, even adding and enriching. Exporters, we can have zero or more exporters that send a copy in a fan-out approach in parallel to exporters. So here we're looking at an example of a tracing pipeline. You can see I'm listening on OTLP and Zipkin. And then what I do is I have a memory limiter processor that then hands things off to the batch processor. That will do our traces in batches. Again, we're talking about traces. And send them out to an OTLP endpoint and Zipkin at the same time. Let's kind of look at an example implementation. Here we have two apps, and they're using Zipkin as the protocol that goes out on 94.11. And in one case, we have an OpenTelemetry collector pod that is sending things off to New Relic as well as to our local Zipkin for just local viewing. I might also want to do Google Cloud, and Google Cloud works a little different for its service account credentials. So maybe I'm running that on a pod or a VM. And so I'm also sending trace data out to there. In fact, I can have one OpenTelemetry collector forward it to another. A little less common, but it's doable. I can also think like a Dapper framework, and the Dapper framework is going to auto-instrument apps between app 1 and app 2. We'll talk a moment about Dapper. Now, what's cool here is my New Relic license key or my Google Cloud credentials are not stored in the app. I'm not baking them in here. These know nothing. They're just sending out trace data to 94.11. It's here at the collectors that I actually have to manage my identity. This means my containers are pure. They simply have tracing enabled or not enabled. Now, when it comes to Dapper, Dapper's a framework that allows us to instrument code. It's kind of a service mesh akin to Console or Istio. And these sidecars are going to allow us to basically send traffic from one service to another. So microservice A can talk to microservice B and just pass things on to a service protocol. And Dapper knows how to have a microservice talk to another microservice. And what's cool about Dapper is it natively supports OpenTelemetry. So it can catch all these inter-service calls and send out telemetry data on behalf, and the apps can be ignorant about how to do tracing and monitoring. So we're going to talk about the receivers and the exporters here that are out of the box. Out of the box for logs, we can ingest logs from Fluent, from a Kafka cluster, or from our OTLP standard. When it comes to metrics, we can get host metrics, again, Kafka. Open Census is supported, OTLP, and Prometheus. This is the most common one. You're ingesting Prometheus metrics from some endpoint. Lastly, we have traces. We get the Zipkin and Jaeger that I told you were kind of standards. Again, Kafka can be an intermediary. Open Census is supported, and of course, OTLP. When it comes to exporters out of the box, for logs, we can send things to files. I mean, we can send traces, metrics, and logs all to just the file system if we want to just aggregate them there. We, of course, have traces going to Jaeger and Zipkin, so they can be both ingest and exporting for Zipkin and Jaeger. Kafka can be a go-between again. And debugs are kind of a handy exporter. That's where we can just output to the console, right? We just want to see the VM or OpenTelemetry pod spewing what it sees to the console. Open Census is supported as an exporter, and again, OTLP. Lastly, I want to point out metrics can be an exporter. Where that becomes really interesting is you can kind of make a poor man's Thanos. What you can do is have a series of Prometheus in different clusters and different VMs, gathering metrics using OpenTelemetry to send them to a central Prometheus where I can then view and graph and alert using obviously something like Grafana. OpenTelemetry contrib. So we have OpenTelemetry out of the box. That's kind of your plain vanilla. OpenTelemetry contrib is where a lot of other companies can add things in here. We can see things like ClickHouse. We can see Loki in here. We can send things to AWS S3. And what matters for us here at WellSky is we use a lot of Google Cloud. So I can use OpenTelemetry to send things out to Google Cloud for monitoring, cloud trace, and logging. And if I have another Zipkin, I can also use this contrib to send things out to Zipkin for traces. Now, what's really interesting here is long, long ago, New Relic had something in the contrib, and they don't. They're noticeably absent. And why? Because New Relic is one of the few vendors that natively supports OTLP out of the box. It does not require you to have the contrib binary. They simply support OTLP as a protocol. All they ask is that you put your API key into a header. So it just makes it super duper convenient and easy to use New Relic in places like the Grafana's new Alloy collector. So how does that apply to here at WellSky? So we have a lot of containerized workloads and a couple frameworks. We have something called Atlas. It's an internal common platform. And what happened is this Atlas framework, .NET focused, bundled the New Relic binary. It makes it super duper easy to gather metrics, but it also kind of creates a problem. I mean, a few years ago, New Relic was browning out, I think, TLS 1.1 or 1.2. I don't remember exactly. But we had a very old version of the New Relic APM agent in some of our containerized workloads. They stopped sending out their metrics, caused some alerts, got some pager duties, and we had to recompile our containers. So when you bundle in something like the New Relic APM infrastructure agent to your container, you have that consequence of now having to recompile with updates, because New Relic will continue to put out features, continue to put out updates, and you should, always have those. It's also fixed to an API key. Now, that can be modified, okay? But in our case, we're just using the out-of-the-box setup. The API key is bundled into the Docker container. That means I'm fixated to one endpoint. If I expire that key because it got out, I have to recompile all my containers to get a new API key. Or in some of our cases, we want to start to separate our workloads. I want to identify my workloads by different API keys for different business units. That becomes kind of hard if they all baked in one single key. And that also means we got to recompile for changes. It's packaging in vendor binaries, which is that tight correlation we don't want to have. It becomes a risk. Whatever CVEs New Relic have, we have to report them as part of our application too. So our desire is to select our endpoints. Maybe in my lowest environment, I don't go to New Relic. I also want to be able to filter at the collector level. We're going to see an example of filtering at the OpenTelemetry collector, but that means I don't have to do something like the drop data feature in New Relic to try to limit my data consumption. I can do it at the collector level, at a much lower level before it ever leaves my clusters. And lastly, this is just good architectural principle about loose correlation and making your containers as small as possible. So I like to bring up CrowdStrike. This is what happens when you have tight correlation. I feel a little bit like I'm throwing stones, but hey, it was about a month ago. So we had to do a lot of fixes with CrowdStrike like everybody else in the world. There was a lot of hand modifying VMs because we had that tight correlation. And I'm always reminded of risks that you can have. So our environments today, a lot of our environments today, at least the ones that have made it to GCP, we have a load balancer that goes to GKE. We use something called Anthos Service Mesh, which is just a fancy Google branding of Istio. That goes to virtual services, which goes to services, which goes to Istio, which goes to pods. So far, this is Kubernetes in a nutshell. But all our pods natively send a New Relic, whether they're lower environments or upper environments, they just go to New Relic. And it works. It works fantastic. But what we kind of want to do is a more scalable implementation. I'd kind of like to prefer in my lowest environments, maybe use kind of all self-contained tools like Zipkin, the application, Prometheus. Maybe I use a thing like ClickHouse or Loki or Elk or F to do logging, and then I want to view them and alert on them with Grafana. My middle tier, I might use some cloud native stuff. Again, we're Google shop, so we're going to look at stuff like logging workspace and CloudTrace. And my production, of course, I'm going to go to New Relic for my production. But in my case, we also want to have some of our logs, because we use something called Chronicle for SIEM. I'd like to have my logs go to GCP logging for my security analysis. So now, to show you visually what this looks like, a self-contained lower environment, we still have that services and pods, but you'll notice here I have this OpenTelemetry collector and its pod, and it's sending out metrics to Prometheus, logs to Loki, traces are going to Zipkin, and Grafana is looking at Loki and Prometheus for me. Now let's look at Google, my all-native Google. I'm now just sending things up to GCP Logging Workspace, GCP CloudTrace, GCP Metrics in monitoring. And now that upper environment, right? I'm still using New Relic for everything, but I can also send my logs over to GCP Logging Workspace so I can do analysis and alerting there. How does that look? So here we can see a basic example. And the top half of this is the same. We have an application that generates traces, logs, and metrics, and they go to OpenTelemetry. That aggregates the data and goes to collector. Both are the same. But on the left side, I'm using New Relic APM. I know it says logs, traces, metrics. Sorry about that. But it's all inside of New Relic APM. Whereas on the right-hand side, I'm using GCP CloudTrace, Cloud Logging, and Cloud Monitoring for all the logs, metrics, and traces. The configuration in OpenTelemetry means I just need to give an identity. I use the exporter Google Cloud. I am using the contrib here, and I could give it a path to the GCP credentials JSON. On the left, you'll notice it doesn't say New Relic, right? I'm using the OTLP standard. I simply use the New Relic endpoint and pack in my API key. I'll be showing you some examples of this later. All right, an example with .NET. So first, I need to have a database. Again, Google Shop, going to do Cloud SQL. And this database is since removed, so I don't care if you see my database string. And because Isaac is using Isaac accounts and I'm paying for it, I'm a cheap person. So I'm using a DBF1 micro. It'll be $13 a month if I forget to turn it off, and my wife won't thump me as bad for that kind of spend. So it creates a Postgres 14. We'll see that I go ahead and set the password for a Postgres user. I'm going to then be invoking something to create an actual database on the cluster, a patient user with a super secret password, and granting it full privileges. We'll come back to this. Before I can connect to it, I'm going to need to enable my CIDR. So I created that Google Cloud instance, but by default, even with the public IP, no one can connect to it. And unfortunately, Google Cloud doesn't provide a command line interface for this yet. So I have to go in there and put my CIDR, see that it applies, and then I can go ahead and connect with something like pSQL to verify I indeed have access. So Ben, back to that script. I'm going to go ahead and run that one that creates the user. So here I'm using the super user, the Postgres user, to go to the database and create the users. And by the way, this little gobbledygook of bash for the cuts and the seds, that's just because the IP address is actually a JSON file with both your public and your private. So now you can see I made the patient's DB and I made the patient user. Fantastic. Now let's create some sample data. I'm going to make some randomized users and passwords, or sorry, users and, some users, first name and last name and social security number and dates of birth, and load the database. Here you can see I'm now using the super secret password. This validates that my connection is good, and it creates a table and loads it. So far, amazing. I can now connect back again, the super secret password, query it, and see indeed, look, those were all made. All right, I get to do .NET. Yay, I get to do .NET. This should be easy. Yeah, .NET. So let's get going. So first things first, I tried this whole demo on .NET 6. It didn't work very good. So I highly recommend moving yourself up to something like .NET 8, it's far more supported. So there's a couple different types of .NET apps you can make. I'm going to be making what's called a model view controller, or an MVC app. So you can see I say .NET new MVC, and the output is going to be an MVC patience. I can then do a .NET run, and hey, look, I made a .NET ASP.NET Core app. Yay! First hello world is done. Next, we got to make a model. That's the basis for everything. Describe your data. So you can see I'm making a patient. It has an ID. The patient has a first name and a last name, a date of birth, a social security number, and the date I created this field. I do need to make the ID. It makes migrations easier later. I'm going to now add some new .NET packages. So these are all NUG packages. So the .NET ASP.NET code generators I'm going to use, .NET EF for migrating database tables, the design, SQLite. Maybe I need the web code generation. SQL Server, maybe I'll go that way. Tools, I definitely need design. I should get PostgreSQL. Yeah, I probably added too many packages, but the ones that matter are the code generator, the .NET EF, and PostgreSQL. All right. I love this. This is what converted me on .NET. I wasn't so bullish on it before. But this .NET ASP.NET code generator, I just pass it the model, a patient, and tell it I'm doing Postgres. And look at all the stuff it made. It made a create, an edit, a details delete. This is awesome. This made so much for me. I'm now going to load my database. I'm going to make a patient table. Again, I'm using those same fields I made in my model. ID, first name, last name, date of birth, social security number. And I'm going to load it with, again, same sample data. You can see it loaded it and inserted it. And this is where I'm going to add a little word of caution. If you use case-sensitive fields and don't add double quotes, you're going to have a bad time. I had so much troubles that because I didn't put double quotes, it kept making patient all lowercase, ID all lowercase, and that didn't jive with .NET. So think about that. Next, I'm going to do .NET EF migrations. So you do .NET EF migrations add, whatever name you want. I said initial create, and then EF database update. And the reason I'm doing this is I was messing with the model a lot as I went along. I was trying different date, time, fields, and formats. So this just keeps your database up to date with your model as you go along testing. I had a lot of errors like this of, UTC not supported, timestamp with time zone. The time zone is -5, which is Central Daylight Time, CDT. And then all these errors. And all I'm going to get to, it took a lot of Googling, is set the enable legacy timestamp behavior. So if you're using Postgres with .NET 8 and you're getting troubles with your timestamps, just enable legacy timestamp behavior and the world becomes easy and things work. So now I have an app that runs. I can go ahead and see that the data is being created in Cloud SQL. I got my selects, my inserts, discards. I can see the details of the patients. Obviously, it doesn't show me the fields. It'd be bad if it's showing me social security numbers. I really wanted to move on to containerizing. So it's great that I have an app that's running locally, but doesn't mean anything if it's not containerized. So I quickly created a .NET container. Again, I'm going to pass some variables. I'm going to explain how I'm doing this in a moment. But I have my host, my database, and my port. Because in some cases, I use something called Ivan to do a free tier of Postgres, but it does it on a droplet and gives me a different port. Here you can see I have these fields of DB host, DB port, DB name. You're like, well, that's cool, Isaac, but how do they get used, right? You got them set here, but how does this happen? Well, I found this really great NuGet package called configuration placeholders. And if you do it after you've created the builder, but before you've done build, you can do something called build, add configuration placeholders, new environment variable resolver, and all the environment variables you pass to container get passed into that settings. And it's fantastic. I've seen other people try to shoehorn in different app settings files that are pre-configured in your build. This is way better because I don't have to bake it in. All right, now I'm going to make a manifest. So this is super secret password 1234 base 64 encoded. I'm put this container up there on Docker Hub 0.1. Got my database settings and the service. I did do this, but I kind of quickly pivoted to Helm. I like Helm a lot better. I got my environment, my host, database settings, and now we're going to go ahead and see this kind of in action. So I kind of glossed over it. I used Cloud DNS to create an A record and a cluster issuer that goes against Google Cloud to get a certificate, but that is a valid URL. You'll find the patients thing there if you go right now. I can create some new users and dates, and what I'm trying to point out here is it's It's a, I'm getting all this for free from the .NET framework, and I thought the date picker was really slick. The other thing that I'll point out is that create a date. It kind of scrolls off the screen when I click the button here, but there's a button that just says today. So I can click the today button and it goes right to the current time. So now I've got some data, details, etc. So let's go ahead and move on to the next, and that is to think about adding the new Relic APM. So at this point we have a .NET app. It's containerized. It's got Helm running in Kubernetes. We've gotten a lot done in 20 minutes. But I want to instrument it. I want New Relic APM, right? So the way I work, because I have a lot of different apps in New Relic, is I give everything a new application name. Some people just share the same key. I like to give an application name per key. And what's cool is when it shows you the code to put in the Docker Hub in New Relic, it does put this in when you copy to the clipboard. It just doesn't show it. So it's great if somebody's leaning over your shoulder to watch. It's not going to put your API key out there. I go ahead and put it in a Docker file, and I'm sure all of you guys are wonderful people, would never use my API key for evil, but I'm going to hide it when I have it on the screen. So right here, lines 18 to 34 is just adding in the new Relic agent. I'm going to build it. Now, because this has my pre-baked container, I'm not going to push it to Docker Hub, because anybody who would pull that image would be sending it to New Relic. So I'm going to use my private Harbor CR that's running in my cluster, and you could use something like ECR, ACR, GAR, whatever your container registry of choice is. As soon as I swap that image out into my Helm chart, boom, I'm seeing data coming into the .NET agent, which tells me I did the right thing. And I really quickly start to see my data in New Relic. I see MVC patience, I see my AppDeck score, I see things like transaction times. I'm getting all my logs pushed through, so I can see the logs with the database there. What's really cool with New Relic is synthetic monitoring. I'm kind of falling in love with it. So they have something called scripted browser that lets you write Selenium. And so here you can see I'm in the screenshot of the created screen. I can go ahead and script out a full test of my framework that not only generates APM, but now I have a built-in QA test going on with New Relic, and I love that. And lastly, because New Relic's aware of my environment, it's showing me that my Patience app is talking to my database. Here you can see I've pivoted from using Cloud SQL to a Postgres running on a MacBook in my network. But this point still remains. I see all these details, including our database connections, inside of New Relic. So what are the pros and cons? Using the New Relic APM this way, it's so easy to implement. I didn't have to touch my C# code at all. The instrumentation is amazing. It is awesome instrumentation. Have no gripes whatsoever there. And we even saw the end-to-end mapping with database calls. Now, the downside to this is that container is always going to send data to New Relic, regardless of environment. Till I expire that API key, it's going to send data. I have to bake in access controls to the container. Because of the key being in there, I can't share it publicly. I got to know where that's going. Because I bundled that New Relic.NET agent, that means I need to update it with every update. And in New Relic's good about patching their stuff, but that just means recompiling to bring in this third-party binary. And even if we were to gather telemetry in other ways, say I drop this container into a cluster that's pulling all of its data into Azure Logging Workspace from AKS, it would still be sending it to New Relic. I'd be doubling up on all my trace data. And lastly, if I check that Docker file into GitHub, I'm going to have to remove that key and have it inserted at build time somehow, maybe use a GitHub action secret, something like that. So we got to start thinking about that key. You don't want to check that in, which I did once by accident. What are my solutions? What are the other trains we could do? All right, we could do a framework like Dapper.io, which would do it for me, again, using the OpenTelemetry collector. I could switch to OpenTelemetry using the New Relic OTLP endpoint, which we're going to do that next. Or, I like to bring this up because in the olden times, for those people that have gray hair or no hair like me, we used to build apps that people double-clicked on computers, right? And you'd have an exe that we'd install with Install Shield or MSI. And that executable, we'd always build what was called a release binary and a debug binary. And the debug was a big fat one with symbols. And it was a common place to always, for all your apps, build a debug and a release. And there's absolutely no reason we couldn't have a New Relic instrumented container and one that isn't instrumented, just 2 Docker files, and build every version of our app twice. It's not that much more to store. And then if we needed to debug, we'd put on the instrumented, and if we were like trying to constrain or control our costs or reduce our data, I'd flip it back to the release. So I do want to point out there's no reason we can't do the build to container approach instead of OpenTelemetry. All right, we're going to add another train to the track. We're going to look at OpenTelemetry. So how do I do that? Well, you notice I'm adding a whole block here. And what I'm going to need to do is decide whether I do 4318 in HTTP or 4317 in gRPC. I'm going to do 4318 in HTTP. I do my endpoint, and you want to end it with that IP in the slash. I'm going to give my service a name. It's okay that I put X's here because I'm going to override this with the settings file. It is Helm after all. And lastly, I love this. Attributes, you can have key value pairs. So I have app equals MVC patients, but you could do things like env equals dev and owner equals billing team and stuff like that. So the attributes allow us to put a whole bunch of more extras into our telemetry output for us, which I think is just really cool. Here you can see I'm setting these values into environment variables, so the OTel exporter protocol, endpoint, etc. And lastly, I want to bake it in the Docker file, though I'm going to override these. Now, key point, when I first started this demo, I was going to v1 traces, which works. But the moment you're trying to see metrics and logs, it doesn't work because naturally, New Relic would throw those away because you're going to the v1 traces. So you want to end at the slash right there. So now I'm going to add the OpenTelemetry instrumentation to my code. So I open up program CS, and you can see I initialize the builder. I got to do this after I add the view controller. And then I'm going to add this OTel resources. And this part here about add environment variable detector is how I bring in those settings I put into my Docker file and pass in with Helm. Now you can see metrics, tracing, and logging, and they're all very similar. They all have the add kind of core implementation. They're going to set that resource builder, which brings in my environment variables. It says where to send stuff. And every one of these adds the OTLP exporter. If you don't add the OTLP exporter, it doesn't go out the door. Lastly, I'm going to point out this commented line, the add console exporter. You can add the console exporter to logs, metrics, and traces and just see the output on the container's logging. So if you're trying to experiment with this without actually sending out traces, logs, and metrics, just use the console exporter and you'll see it spewing in your container's logs. I launched it, and honestly, this is one of the few times I ever did a piece of code and it worked the first time. It just worked. I started to see trace groups. I see my gets and my posts. You can see that I have all the distributed tracing data in here. You can see the spans are coming in. I get span details, so I can see duration, throughput, average duration. But consequences, the span doesn't necessarily tell the database name. And so I would have seen service to service if I had multiple services in my environment, but I've lost that connection to the database that I got from the FAT client. So I have to be aware of that. Let's do a little demo here. So I'm going to go ahead and check my cluster and see that I have my pods and I have my services. I'm kind of glossing over the ingress, but you can see that the ingress is listed there under the services because you can see it with the host. And then next I'm going to click some patients, patient portal. I'm going to go ahead and maybe edit some fields, save some values. I don't know, change the social security number, save it. Let me see, what else should I do here? I think I'm going to go look at New Relic. So I'm going to go log into New Relic. And I'm going to go ahead and pick my APM services. And because I had used the FAT client, it still has it at the top, but I'm going to use OpenTelemetry this time. I click it, and I'm kind of highlighting the fact there's some data because its first thing it wants to do is say, hey, you want to buy some more stuff? I don't fault New Relic for getting me to try to upgrade, but there's no data. Why is that? Well, maybe I need to go check. I'm going to go open up my Helm chart. Oh, I don't remember what the name was. So let me do Helm list in my namespace. There it is. It's my patient MVC. So I get the values of the my patient MVC in the patient's MVC namespace. And you're going to see as I played a little trick on you, what I did is I had changed it to send all my trace data to localhost 4318, which is a completely valid URL, but nothing's listening to it. It's like a phone call that's a valid phone number, but no one answers. So that means my OpenTelemetry client going on in my, or the OpenTelemetry code going on in my .NET is just throwing it all away. So it's a really cool way that I can just shut off the spigot if I want to stop sending traces, logs, and metrics. So then the next question becomes, what do I do next? So you can see here, I got that 4318. So again, as much as I trust every one of you, and you're all fantastic, wonderful human beings, I'm not going to show you my new Relic API key. Instead, I'm going to go ahead and set it to an environment variable. I think I called it my NR key. It was set up earlier. So now I'm going to launch that Helm chart. Note, same container. I'm still doing the same tag and the same container name. All I'm changing is the API key and the endpoint. I launch it. I do a watch to see when my pods rotate. So here they've rotated. And then now I'm going to do a little bit of actions. So I refresh a few times. I have a little thing that does it for 100 to do some patience. Now I'm going to skip ahead a little bit because we have a lot to get through. But I essentially post some data and I come back to New Relic. And what I'm going to see here is I have my trace data back. So this turned the trace data back on. I can look at things like transactions. What I'm not going to see is when I click on the databases, it won't show me the databases because it doesn't know of the databases in this context. But that said, if I go to logs, I can go ahead and see my log data. The other thing that I can see is if I go down to the metrics explorer, which I'll do next, I can see any of the metrics I collected. And while they're not all that interesting, you can see in there I'm getting things like the active requests and the Kestrel ones, which are the two I picked. Again, I wasn't trying to pick a lot of metrics. I just wanted to show I could send metrics into the system. Lastly, I'm going to skip again ahead. If I go into all instances and go down to my Postgres, because I instrumented my database, I still have everything I'm gathering from my database coming in to New Relic. And that's through the New Relic VM client that's talking to Postgres in my environment, not through OTLP. All right. How might we do it with CloudTrace, right? We talked about OpenTelemetry. I now want to go to my own Google Cloud. So here I'm going to create a service account. I'm going to get the JSON file. I'm going to need to give it the metric writer, the CloudTrace agent, and the logging writer permissions, the three main things you need. I'm now going to go ahead and launch this OpenTelemetry collector on my Docker host, which is right over here. And you can see that I do Google Cloud, and I'm going to do the memory limiter and the batch processor. So listen on OTLP, do these two sequentially, and send it out to Google Cloud. And because I'm running on a shared Docker host, I put a 5 in front of the port, so you see 54318 and 54317 to do 4318 and 4317. Now back in that Helm chart, I've now set my endpoint from the New Relic one to this Docker host with that 54318. What happens here is we can go and see that I'm not getting any traces at the moment, right? But if I go ahead and refresh, and I'm going to do a couple changes, maybe click edit a couple times, change a field, save it. Yeah, I have a little bit of a problem when pods first rotate there. That's just a K3S problem I have. Refresh the details. I'll do one more refresh. Now when I go to CloudTrace and refresh, you're going to see on the right-hand side, indeed, now I'm sending things up to CloudTrace using OpenTelemetry, and that kind of combines my logs and events inside of environment. So I can do Google Cloud using the OpenTelemetry collector just as well. I can see that I have spans in here. I'm not going to get too far into it, but you can see the metrics in Google Cloud. And lastly, logs, right? I can get the same logs in there, and it commingles it. So the things in the orange at the top came from a load balancer used for a cloud run, but these logs all come from OpenTelemetry. Next, I want to talk about Zipkin, right? So with Zipkin, I'm going to go ahead and launch Zipkin. This is the Zipkin, the app, mind you, not the protocol. I installed it to my cluster, and now I have Zipkin running on 94.11, and I can go ahead and view it. This is what Zipkin looks like out of the box. Pretty bland. It's just kind of a very basic, it's like looking at Notepad to Visual Studio Code. This is the Notepad, right? Just show me traces. Now, I'm going to want to route back to Zipkin for my OpenTelemetry collector on the Docker host. So what I'm going to need to do is create some sort of ingress that my Docker host can see. So I gave it, again, add a node port. So I can access it either on 94.11, that's one of the actual physical VMs, not VMs, physical computers in my network. And this is the node port also on that cluster. Now we're going to go back to OpenTelemetry where I can send things to both Google Cloud and Zipkin. Or we could have done this to New Relic and Zipkin much the same way. So you can say, I'm going to Zipkin on the spans. By the way, if you're ever doing this with ChatGPT or OpenAI or ChatGPT or Copilot or Gemini, it'll keep saying do Zipkin v2 spans. So it's got some bad data in there. It's API v2 spans. Note, I didn't have to change my Helm chart. I'm still going to the same collector. I'm just modifying my collector at this point. And now I can see that I get Zipkin traces and Google Cloud traces at exactly the same time. And what I want to point out is this becomes really handy if we're trying to look at things like maybe we're trying to migrate away from Datadog into New Relic. This would be a way we could do it. We could say, all right, we're going to send to Datadog while we're doing the migration, but then I can change my collector to now go to New Relic to show the value. Maybe I'm doing it to Zipkin and a third-party vendor. Again, this would be using the OpenTelemetry config. I could do that kind of thing. Maybe I'm going to New Relic inside the collector as well. That's what I was talking about. And this is that header block where I'd have that blah, 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 NRAL. So my New Relic API key is right here, and it's brought into the endpoint, and this would be a valid configuration. You notice the format's a little different. This is because this is from Grafana Alloy. Lastly, maybe you're pulling away from some third-party lightweight one. So, maybe you went with ground cover and you're now moving to New Relic. You could use this and then do the two ones, one to ground cover and one to New Relic. I mentioned I'd talk about processors. So the top one's a filter. So maybe I have an application environment. I actually have an environment like this where I have billing, patience, and EMR. And so all I want to do is throw away all the traces, logs, or whatever I'm using this processor for. So let's just say that I'm using it for traces. I want to throw away all the traces that aren't for those three services. This becomes a way I can filter at the collector level. The second processor is a way to enrich data. So if I'm using this attributes account ID processor in my sequence, it would add a key called project ID and set the value of HHHDev, which is one of the internal BU names I have. And the action there is inserted. So it would be adding this value, if it doesn't exist, to all the data going through that processor. So, in summary, we looked at making a new .NET 8 MVC app, and we laughed at my terrible C# skills. We tied into PostgreSQL, both Cloud SQL and a local PostgreSQL server. We instrumented with New Relic out of the box in Docker. We looked at OpenTelemetry. We even showed some examples of fanning out with OpenTelemetry, looking at New Relic, GCP, as well as a Zipkin. I want to point out, like I said before, you can do the bundling of the third-party binaries and have two different containers, or use OpenTelemetry. Both kind of mitigate the risk if there's an outage or you need to update things on the side, right? If you share a bundled APM key, like your New Relic API key, you're going to have a bad time. And if you bundle it in a container, if somebody has this bundle in a container and you fix it, but you're allowing them to clone the repo, it can just come back again. So pay attention to that kind of thing. Lastly, I'm going to leave you with a little Drake. Bundle container, configured with Helm. Again, that's maybe my opinion. Thank you so much for letting me talk to you today. I'll leave these codes up for a minute. All the code I showed you, the Helm charts, the Docker files, that terrible MVC Patience app is over in that GitHub repo that's public. And then I have a blog where I'm regularly writing about all sorts of tools, including New Relic. I invite you to check it out. And again, thank you guys so much for letting me speak to today's conference. Wish I could be there in person. I'll definitely see you there next time.